Okay, this is a uniform motion problem, or at least I'm assuming it's uniform motion. It's, rowing in a river. There's a crew. They row at a consistent rate, let's say. Let's say the river is also consistent. And so I'm kind of read it. It says, and when I read, I'm going to draw a little picture. It says the crew rows 16 and a half miles upstream. All right. And that's miles, by the way. Maybe I should put that down, miles. And then it goes back downstream. And downstream, it does 18 miles. And again, these are miles, all right? And it says it can do it in 9 hours, and that means up and down. So I'm going to say the upward journey was X hours, and the downward journey would be 9 minus X, all right? And then it says, furthermore, it does something else. It says upstream 21 miles. I'll put that down. Yeah, kind of a visual, but I'm not saying my visuals are accurate. So 21, and again, this is miles. And then it goes upstream 21, right? And then 19 and a half miles down. Well, I'll write this over here, 19 and a half. And these are miles. And how long will it take? 11 hours. So what does that mean? Well, I'm going to say y upstream and then 11 minus y downstream. So now comes the question is, what are you going to do with that information? You need to come up with something that's equal, all right? So what I want to claim over here is looking at it, I want to claim that if it's a uniform motion problem, the rates upstream must match. They must match. So what's the rate? The rates are going to be distance divided by time. So that means 16 and a half over X must be identical to 21 over Y. I want to circle this over here. That's fine, we got that. I'm also going to claim that the rates downstream must also match. Let's write it down. What's it going to be? Distance divided by time. So you can get 18 over 9 minus X equals 19 and a half over 11 minus Y. All right, I'm going to circle that for you. Now, the bottom line is, getting through the reading of it, writing down what they said. Now comes to the part where I have to stop thinking about what I read and start solving a system of equations. And let me go to the whiteboard to do that. All right, as I go to the whiteboard, this will disappear. And you got to keep your eye on the ball. What's the ball we got to put down is the equation we got. And I'm going to write them down for you now in a slightly different form. And the reason for that is I want to get rid of the fraction. And I'm going to write this as 16.5y. That's 16.5, right? Y equals 21x. And I'm going to write the other equation down as 18 times 11 minus, I'm just clearing a fraction, by the way, equals 19.5 times 9 minus x. All right, kind of nasty looking, and then, I find it to be nasty looking too, but let me make sure I got a copy down right. 16.5 times y and 21x. I think I did okay there. And then, let's see, 18 times 11 minus y. I did okay there. And 19.5, 9 minus x. And what I'm going to do is I'm going to look at this first equation here, and I'm just going to get rid of the fraction initially. What I mean with that decimal part. And I'm going to multiply by 2. So it's 33. And that's going to be 42. All right, let me see if I did that right. 2 times 16 is 32. And 2 times 0.5 is 1, so 33. Yep. And what I'm noticing about this over here, it kind of reduces nicely. So I'm going to say, if I looked at that, I could divide that through by 11. I'm sorry, by 3. So it's 11 y equals, and 3 goes into 42 14 times. Let me just check that. So 3 times 11 is 33. 3 times 14 is 30. And 12, 42. I feel good about that. All right, now I'm going to look at this other guy, and kind of nasty looking, but I'm going to multiply both sides by 2. This is 36. 11 minus y equals, that's going to be 39. And then 9 minus x. All right? And I guess what I'm going to do is, I think I'm going to multiply it. All right, so what would you get? 360 plus 36. I'll write this down for you. And that's going to be 396. All right, minus 36y. And now I got to do 9 times 39. Well, 10 times 39 is 390, minus 39. And that's going to be 351. I'll write that down for you. Certainly you can do it another way. 9 times 9 is 81, and 9 times 30 is 270. And if you add that together, you would get 351 minus 39x. All right? By the way, I'm going to start to erase my baby arithmetic. A lot of students do that in their head, and there's nothing wrong with that. And believe it or not, you can take a different path to the answer as well. All right, I want to kind of maybe write a little bit differently. And what I'm going to do is 396. Whoops, sorry about that. Minus 351. And that gives me 5 and a 4, so 45. Let me see if I did that right. 51, 61, 71, 81, 91. Yeah, 45. Minus 36, minus 39. That's not bad. Okay? I'm going to erase my baby arithmetic again. And I'm noticing something about this as well, that it's also divided by 3. So I'm going to divide both sides by 3. Just to make it easier for me. What do you get? 15 minus 12y is equal to minus 13x. Well, you know what I'm going to do now? I got something here, don't I? I got this. And I'm going to use this now to eliminate one of those letters. So I'm going to say y is equal to 14 over 11x. Let's write that down. 15 minus 12 times 14 over 11x, right, just using that, equals minus 13x. Well, I got some work to do, don't I? And the first thing I want to do is get rid of the fraction. So I'm multiplying both sides by 11. So 11 times 15 is 150, and 15, which is 165. Minus, well then I'd get 12 times 14, right? And let me do that for you. 10 times 14 is 140. 2 times 14 is 28. That's 168. And 11 times 13 is 130, and 13, which could be 143. Then I get my eraser, get rid of my baby arithmetic. And I realized a lot of students, they don't even know what x or y is anymore. Doesn't really much matter. I'm solving for x and y almost in an abstract way. So you get 165 equals, well, let's see, 168 minus 143. Well, that would be 5. You get 25. Let's make sure I did that right. Let's see. Yeah, 168. Not bad. Well, I got to keep going. X would be equal to 165 over 25. Well, I'm going to reduce it. 5 goes into 25 5 times. 5 goes into 165 33 times. Let me make sure I did that right. 5 times 30 is 150, and 15 is 165. Yeah, so I got it. And I'll write this one down for you. X equals Well, that's going to be go 6 times, right? 6 and 3/5, or 33/5. Let's get the y. By the way, you may not have any idea what these things are, and it's fine. Right, I'll write this one over here. Y is 14/11 times 33/5, right? Well, 11 goes into 33 3 times, and 3 times 14 is 30 and 12, which is 42/5, which goes in 8 and 2/5. I'll write that down for you. So y is 8 and 2/5. Again, I want to make sure you know I just did this over here, which is 42/5. All right, so I have no idea what the problem was. You go back and read it. I mean, you got some x's and y's here, right? So, looking back over it, I definitely see they got this number here, and I definitely see they got that number over there. So, but I don't know, I don't think that was the question. And someone says, do you remember even what x was? X is hours. So this is 6 and 3/5 of an hour. And again, I'm not saying that was your question. And what's this over here? Well, this is going to be 8 and 2/5 of an hour. Okay, what was the question though? Find the rate in miles an hour of the stream and of the crew. Well, that's a completely different question, isn't it? So I'm going to, put that down. It's a more difficult question now. So I'm going to say the rate upstream. We did that before, right? And what was the rate upstream? It was either 21 divided by y, or we would have written down 16.5 divided by x. Well, I'm looking at this thing, and I'm going to write down 21 divided by y, which is 42/5. I'm going to write this a little bit differently. I'm going to write it as 21 divided by 42/5, which is the same thing as 21 times 5 over 42. I'm going to reduce it, and we're talking about rate upstream, by the way, by using a factor of 3, and 3 goes into 42, 14. Whoops, sorry about that. Right? Oh, what am I doing? I'm sorry. I'm daydreaming again. That's crazy. That was 42, right? And let me get my eraser out again. 21 goes into 42 times, so it's 5 over 2. Now, what does that mean? It means it's 2.5 miles, 2.5 miles an hour. And this is really the rate of the boat and the stream. All right, that's the rate of the boat and the stream. So I'll put this over here. That 2.5 miles per hour has something to do with the rate of the boat and the stream. So I'm going to say x. Maybe I shouldn't use x. I used x already. It's a tough problem, though. I know that. Let me get my eraser out. Erase that. I'm going to say b is the rate of the boat, and s is the rate of the stream. So upstream, what's happening? Well, when he's going upstream, right, the current's taken away from him, so it's going to be b minus s. All right? Okay, let's do the downstream rate now. And the downstream rate, I'll write it over here for you. The downstream was 18 over 9 minus x, or you could have done 19.5 divided by 11 minus y. Well, you know what? I think this one might be easy to do. All right, so what do you get over there? And I can write it down for you. So it's 18, 9 minus x. Well, that's 33/5, right? And again, this is the rate downstream. That means they're going with the current, by the way. I can multiply by 5, top and bottom. For 5, that would be 50 and 40, 90. 45 minus 33. And that's going to be what? 90 over 45 minus 33 is 12. Let's see, 45, 6. I'm going to divide by 3, 15 halves, or 7.5 miles per hour downstream. And let me write that down for you. Downstream is 7.5. And that's going to be the rate at which they can row, the boat rowers, plus the stream. I got 2 equations, 2 unknowns. Yeah, it's a tough problem. B minus S. I'm going to add this together. And what do you get? Let's see, 7, that's 10. 2B. So the rate of the boat is 5. So the boat in still water is 5 miles per hour. All right, we'll look at the key later. And I think I can do the stream. The rate of the stream, or the river, is what? Well, look at any question you like. It really doesn't much matter to me. I'll look at this one over here. So S is going to be what? It's going to be 2.5 miles an hour. Let's look at the key and see how we did. And it's really kind of a tough problem. So let's take a look at the rate of the crew in still water is 5 miles per hour. We got that right. And the rate of the stream is 2.5 miles per hour. Again, I consider it a good problem because it really requires steps in thinking through it. It really does require steps. And you know, the problem with taking steps is you may say they never end. This really wasn't a long problem. And don't see these things as long problems, right? See them as entertaining problems, if anything, right? What are they really entertaining? Not only entertaining, they're educating you. And that's the important part here. Thank you so much for paying attention now.